Right, in this video we will discuss our question 9 for this question paper November 2017 Physical Sciences paper 1. In the description below uzothola ama links for amanye questions akhona in this question paper. So lana it's question 9, electromagnetism. So mawuthatha ukubheka, we are given two sketches. One is a sketch of a coil between two magnets, and then the other sketch look a graph between EMF as well as the inverse of time, or 1 over the change in time. So bese bathi an induction coil of area 48.6 cubic not cubic, square centimeters and 200 windings is rotated clockwise in a constant magnetic field of magnitude 2.4 Tesla. Refer to the diagram below. So this is it. Yeah, it's a circular coil by rotator clockwise, and the magnetic field strength is 2.4 Teslas between the two magnets. And then the graph below shows the induced EMF. Actually, according to Faraday's law, we know that if we rotate a coil or move a coil within a magnetic field, you induce in EMF. So the EMF produced kule coil was plotted in this graph against the inverse of time. Right, ku 9.1 bese bathi state Faraday's law. So Faraday nangula E equal to minus n change in omega divided by the change in time. So basically the EMF induced in a current carrying in a conductor is directly proportional to what? To the rate of change in the magnetic flux linkage with the conductor. So now Faraday's law, actually about him state in words now, the formula for Faraday's law is this one. So this formula still is a capture these words. These words are contained in the formula. So 9.2 use the information and the graph to calculate the change in magnetic flux. So in the sketch we are born with, okay, lana, let's see what we are given. Since ngifuna the change in magnetic flux, ngiyosebenzisa le formula ka Faraday's law. Faraday's law. So I need the EMF. I also need the value for n, which is the number of windings is given, as well as delta t. So using the graph to calculate the change in magnetic flux, ngiyodinga the EMF, which ngakhona ukuyithola on the graph, as well as the time. I'm given n, which is 200 windings. So bheka now, since this is a straight line and the straight line has ama points amaning, so in other words it has good lana, you can use any point oyifunayo la. You can use any point you want. Bheka, as keep it data la, it's 200. EMF is equal to, let's pick a point, let's choose a point at the started this one, Lenaga 2. So the EMF at this point is what? Is 2. So it's 2 volts. And then the inverse of time ihamba ngo 0.2. So it's 0.2. Lana it's 2, 4, 6, 8. 0.8, another 0.9 to 0.2 total 1. So it's 1 lana, and then plus 0.2, it's 1.2. So it means 1 over delta t is equal to 1.2. 1.2 inverse of a second. So now we calculate the change in magnetic flux using Faraday's law. So it's minus delta omega divided by delta t. So you substitute kanjani le values or understand that in a moment. EMF is equal to minus n delta omega. I think I divide here this time ngizoti times 1 over delta t. So nangabe ngifuna ukuseparator do delta t from this fraction lena, this is what I get. Ngithola 1 over delta t. So this value now 1 over delta t is actually multiplying la, not dividing. So EMF 2 minus n 200 delta omega unknown times 1 comma 2. So therefore delta omega is going to be equal to 2 divided by minus 200 1 comma 2. Let's calculate again, man. All right. So we go 2 divided by negative 200 times 1 comma 2. Answer is negative 0.0083. Negative delta omega, it's negative 0.0083 Weber. So this is our final answer. Now sisiyaku 9.3. The coil rotates through an angle of theta. Theta, this is the initial angle, to a position where the magnetic flux becomes ubani u0, and we know ukuthi magnetic flux nangabe iba u0, the angle becomes what? 90 degrees. If a magnetic field line is parallel with the normal line through iloganje surface area yakho, if they are parallel, it means if they are perpendicular, not parallel, but if they are perpendicular, it means you have what? You have a magnetic flux. Magnetic flux yako is over equal to 0. So lena, okay, I think erase lana, and then we can calculate to 9.3. So 9.3 siyazi ukuthi magnetic flux is calculated as omega equal to magnetic field times area times cos theta. Since it's in a start to calculate the change in magnetic flux, it means it's magnetic flux final minus the magnetic flux initial. So therefore the final one will be a, let me open a bracket since the BA common ngapha nangapha. So lana kuba cos theta final. The only thing I change here is the angle. The B and the A remain constant. So that's why let's take them out as a common fact. So like about cos theta initial, change in omega, change in magnetic flux. Now the change in magnetic flux we calculated on the previous question as negative 0.0083 equal to what's B? It's given 2.4. Now the area is given as square centimeters. Let's convert it to ama square meters. So we answer it to la. Now converted this square centimeters to ama square meters. The answer la komele kube 48.6 times 10 to exponent minus 4. Komele divide ngo 10,000 kahle kahle. Right? Komele divide ngo 10,000 in bracket like about cos cos 90 degrees, since the final angle 90 minus cos theta initial. Right, now we calculate basically like about 0 la nakuzoba 0 la. The cos 90 is 0. Yeah, it's 0. So therefore i-answer yami la izoba ubani. Let me do this. It's negative 0,0083 divided by 2.4 times 48,6 times 10 minus 4 equal to minus cos theta initial, or I can just cancel out labo negative, since nang divide on negative 1 both sides ngithola ubani, a positive value. So ngifuna the value for this, ngizothola u 0.0083 divided by 2.4 times 48,6 times 10 to exponent minus 4 equal to, let's take it to 3 decimal places. Answer is about 0,712, is it? Yeah, 712 equal to cos theta initial. So cos theta initial is equal to arc cos of 0.712. So answer yethu kuba ubani? Yay, arc answer equal to ngithola u 44.664. Theta initial is 44.64 degrees. So this is the initial angle, the angle for theta ebathi calculate la ku 9.3. So thanks for watching video etiphelela lana. Nangabe uyi-enjoyile, leave a like, ungakhohlwa ukusubscribe nangabe new to this channel. In the description below uzothola amanye ama-videos, links to other videos for this question paper. Nangabe uyi-enjoyile, share nabangani bakho as well. Yeah, so the video ends here. Thanks for watching, guys. Bye bye, asibonane on the next one. Peace.